We have a frog here in a pod. What? And this pod just floats without sinking. Just floats without sinking in a fluid of density. So we got 1.35. Hey, the unit on this, they're giving us chemistry units here. Typically in physics, we want kilograms per cubic meter. So when you convert this, this is the same as 1,350 kilograms per cubic meter. I'm going to go physics units. This the radius of the pod, 6 centimeters, 0.06 meters. So this is a quick problem. So we look at this frog here. Let's call him a toad. He's a toad. You know why? You'll see in a minute why I'm changing. He's not a frog. He's a toad. So we don't conflict. So because we got two F's here. We got fluid and frog. Fluid and frog. So we'll have fluid and toad, so we can keep track of our variables. All right. So what's the downward force here? We got. What's the downward force? mg for the what? The toad, right? And then what's the upward force? The buoyant force. Now, what does Archimedes' principle tell us about the buoyant force? Buoyant force will always equal the weight of the displaced fluid. So that's going to be mass of fluid times gravity. Okay? Now, we sum the forces. So we're going to have mass of fluid times gravity up, mass of toad times gravity down. That's going to equal ma, where this is mass of toad. Oh, one thing here. Notice I'm not including the pod, the mass of the pod. Why am I not including the mass of the pod? It tells us negligible mass. In other problems, like what if they did give you the mass of the pod? You'd have to include that. You'd have to be like, all right, then we have mass of the pod. We have to include that in the problem. But here, they told us that the pod is negligible mass. Okay, so is this pod accelerating? Nope, so that goes to 0. So basically, we have mass of fluid times gravity equals mass of toad times gravity. Gravity drops out. Okay, so we got mass of the fluid equals mass of the toad. Now, we got to do some substitution here. Because what ultimately we're trying to figure out the mass of the toad. We're trying to solve for this. How much does that froggy weigh? Well, we got to do some substitution. What can we substitute in at this point? Density is mass over volume. So what's mass? Density times volume. So we're going to plug that in here. So I'm going to rearrange. I'm going to flip this. So the mass of the toad, I'm going to flip this equation around. Mass of the toad is equal to mass of the fluid. Well, what's mass of the fluid equal to? Density of fluid times volume of fluid. And then we got the density of the fluid. They gave that to us. So what's the volume of the fluid? Well, what's the volume of a sphere? The volume of a sphere is 4/3 pi r cubed, right? But what is this, a whole sphere? It's half of a sphere. So we got to divide that by 2. All right, so when you plug in, so take this radius right here, plug the radius in. When you punch that into your calculator, the volume of half the sphere is 4.524 times 10 to the negative 4 cubic meters. That's our volume. That's the volume of the fluid displaced, right? The volume of the displaced fluid equals the volume of the object submerged. So now the mass of the toad is going to be density of fluid 1,350 kilograms per cubic meter. The volume of the displaced fluid is 4.524 times 10 to the negative 4 cubic meters. The cubic meters cancel, and we get the mass of the toad equal to 0.6 kilograms. 0.61. Or 610 grams.